Okay, today under electrolysis, I'll be going through selective discharge. When an ion or metal is being reduced at the cathode or oxidized at the anode, the species is being discharged by the electrolytic cell. What happens at the cathode? When there's more than one species present at the cathode, the less stable species is selectively discharged. When determining which cation is preferentially discharged, we need to take a look at the reactivity series of the metal, which is shown over here. Please stop calling me a zebra. I like her cooking super good. So when you look at the reactivity series, you will know which one is the hardest to discharge and which one is the easiest to discharge. The ions of less reactive metal like gold, silver, and copper are less stable compared to those of the more reactive metals. As such, the ease of discharge increases down the reactivity series. An electrolyte containing both hydrogen and copper ions will selectively discharge copper ions to produce copper metal. Why? Copper is lower on the reactivity series compared to hydrogen. Then what happens at the anode? Do take note that sulfate and nitrate ions are never discharged. The ions are very stable. So if you look at this table of reactivity series, fluoride ion is the hardest to discharge. Similar to cations, as the halides become less reactive down the group, the ease of discharge of the halides increases. An electrolyte containing both chloride and bromide ions will selectively discharge bromide ions to produce bromine gas. Why? Bromine is less reactive compared to chloride. Hydroxide ions, also known as OH-, are easier to discharge compared to halides, and in most cases, OH- ions are selectively discharged. Reactive metals, not ions, tend to lose electrons to form ions. Reactive electrodes, like copper, tend to be discharged at the anode more easily than ions. And that is 2 minutes of chemistry. See you next time.